We're at the Alfred Merritt Smith Water Treatment Facility here, actually in our chlorination facility. Our chlorination facility was originally designed to be able to provide disinfection for the water treatment facility, but also in mind at that time was the possibility of us having a quagga mussel infestation. So we actually have the capability of being able to feed to our intakes from this facility. Here you'll see that we have several different chlorine feeders. Basically what happens is we receive chlorine by trailer. That chlorine then goes through an evaporator system, and after the evaporators it goes through these feeders here where chlorine goes, and we can meter the amount of chlorine to dial in a specific dosage, which is really important because we've been able to determine what dosage that we need to utilize in order to prevent the mussels from settling, attaching, and growing in our pipelines. If you look at the array of piping that's here, we have several different chlorination points, and we also have a lot of spares because one of the things that we're realizing is we've got some new infrastructure that we're putting in place, like our new intake, intake number 3. We're going to have the capability of being able to provide chlorine out for intake number 3 with some of this additional piping and infrastructure here too. So basically, this is the point where all of the gas, the chlorine gas that we use, gets distributed out to all parts of the facility, including what we use for quagga control. The way that we're set up here at Alfred Merritt Smith and River Mountains, actually for all of SNWS, the Southern Nevada Water System, is that currently we have 2 intakes. Intake 1 was the original intake that provided water to Alfred Merritt Smith. Intake 2 was put in place when we put in the River Mountains Water Treatment Facility. And Alfred Merritt Smith has a very short length between the lake and the plant. It's a very, very close proximity. River Mountains has a long length of over 5 miles of raw water infrastructure. So basically what we're doing and what this has allowed us to do is to be able to chlorinate at the, for the River Mountains intake, the long intake, at the point of intake. So as the water comes in from the lake and into the tunnel, even before it gets to the pumping plant, we've chlorinated that water. At Alfred Merritt Smith, we are chlorinating at the pumping plant currently right now, and that is being used for quagga control coming to this facility. So in the future, we have another intake, a large intake planned, intake number 3, and we are planning on chlorinating using disinfectant at the point of intake for the new intake as well. So this facility and the chlorination strategy that we have right now is planned to be used for those facilities. What we have right now in our strategy for dealing with the mussels is that we are chlorinating at a point just inside the pipeline where we bring water in at intake number 2, for instance. Our overall strategy is we do get infestation on the screens and the grid where the water comes in, actually in the lake, and we're doing mechanical cleaning of that every 6 months right now, and inspection and cleaning as required. So we do see infestation that occurs there, and that's how we're handling that. Then once the water gets into the infrastructure, because it's in the presence of chlorine, they don't settle and grow and colonize inside any of the infrastructure that we have. So cleaning the screens and then chlorination right now is our preferred method. It's very, very effective in dealing with these quagga mussels. Well, there's really 2 costs that you have to consider. The first cost is the routine cost of just the chlorination and the operation of the facility. I would say that's somewhere around $300,000 a year for us, that type of number. It's a little bit less than we originally thought, just because of the potency of the chlorine as it deals with the veligers and the quagga mussel problem. Very, very effective in dealing with that. The other costs you really need to consider are the capital costs. And the capital costs have been relatively significant in the fact that we've had to add infrastructure at both of our intakes, and we're having to add infrastructure in the 3rd intake, a pipeline all the way out to the point of intake, and the materials of construction are such that that's going to be more expensive than we originally thought. So there's a relatively hefty capital component just to have the infrastructure in place to deal with these things. For IPS 1 and IPS 2, The existing intakes, the capital number is probably right now we're looking at right around about 300,000 to 400,000 total between studies that we've done and infrastructure that we've put in place. For intake number 3, we are putting in, that particular project is an interesting project because we're not planning on being able to get down into that tunnel for many, many years. So we had to choose a material construction that was going to last for a long period of time. And so we're looking somewhere in the $10 to $15 million range just to run the pipeline from where the intake is being drilled all the way out to the point of intake. Right now we're using chlorine as a disinfectant. In the future, we've talked about various different options. We've talked about potassium permanganate, we've talked about maybe monochloramine, we've talked about different things we might be able to use. And so because we are only going to have really one shot at putting this pipeline in, we had to put a pipeline in that was going to be able to handle a wide array of chemicals. And so it's a pretty expensive endeavor. If we didn't have any of the quagga control in place, we found that from the time that we realized that we had a quagga mussel infestation in the lake until the time we actually got the chlorine turned on, we began to have infestation in our infrastructure. We were taking apart small lines that go to instrumentation and finding that there were quagga in there. We were doing some physical inspections just as a result of changing out pipes and pumps, and we found them in that 5-mile raw water line over to the River Mountains water treatment facility. So we know that had we not put something in place to control this infestation, that we would have quite a bit of problem in our infrastructure, and that could cause us to go anywhere from it being a nuisance in some parts of our pipeline to potentially shutting off the water supply. So it's definitely significant.